Okay, everybody. So today we're going to kind of do a combo item of things that are working ahead and things that are old, because the topic itself you probably haven't seen before, but the stuff you need to know to do it is all kind of old stuff that I think people need more practice on. So it is simplifying radicals. Now, if you recall, radicals, this is a radical, a square root sign, and if you make it a cube root or a fourth root or whatever, it's still called a radical. I love the word radical for this because a lot of times people use radical like in politics, and people use it as a bad thing, like, oh, they're too radical. But the origin of the word radical is that it gets to the root of a problem, which is why roots are called radicals. And that's why in politics and stuff, it's silly that radical is considered a bad thing because we should always be striving to get to the root of a problem, right? So I like to reclaim the word radical in math and in current events. Okay, so simplifying radicals. Now, if you saw square root of 16 under a radical, some of you would see that and instantly know that the square root of 16 is 4. Okay? But if you saw something like square root of 32, okay, now 32 is not a perfect square. No whole number squared equals 32. But we can simplify 32 from knowing that 16 times 2 is 32. So basically, here's my general rule. You can split up square roots when you have two numbers multiplied here. So square root of x times y is the same thing as square root of x times square root of y. You can break it into two roots. That only works for multiplication, not addition, okay? So if I know that 32 is square root of 16 times 2, right? Then I can make that be square root of 16 times square root of 2, right? This is just applying this. So this is me recognizing that 32 is 16 times 2, and that's just something you got to recognize, and then splitting it up into two square roots. And now I know that square root of 16 is 4, so I can rewrite this as 4 root 2. And that is a simplified radical. Okay? Square root of 32 is 4 root 2, because we basically pull out a perfect square, and then you have what's left. Okay? So that's essentially what we're going to be doing today. Now, you probably haven't done this before, so in that sense it's a new topic that you're going to use in math next year probably. But in another sense, the main work of it is simply knowing how to factor numbers and recognize perfect squares. And that's kind of old stuff that you have done for years, but a lot of people don't do it very well still. That's okay. That's why I'm here. So the first thing you're going to have to do in order to do this efficiently is to know your squares. So over here, 1 squared is 1, 2 squared is 4, 3 squared, 3 times 3 is 9, 4 squared, 4 times 4 is 16, hence that. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. I'll stop there for now. We could go on. I have room on my board. I'll go down to 12. 11 squared is 121. and 12 squared is 144. Okay, and I'll put those in some kind of document on the Google Classroom. Okay. The other thing that's useful is simply knowing how to factor your numbers, and I think the best way to do that is a factor tree. So let's try square root of 112. Now, off the top of my head, I don't know what factors this is, but I can figure it out with a factor tree. So, starting with a factor tree, you just find two numbers that multiply to make 112. Any two numbers. For me, first thing I do is, if I don't already know something that's a factor of 112, the first thing I do is look and see if it's an even number. And it is. So any even number, you know that something times 2 equals it. Okay? So what times 2 is 112? Well, let's figure out what half of 112 is. Half of 100 is 50, half of 12 is 6. So 56. And once you get down into something that's a normal times table, those of you who know your times tables, it gets a lot easier. But let's say we don't know our times tables, and we're just stuck with 56. We're like, okay, what do we do now? Well, 56 is also an even number. So I'm going to split it with 2 again. Put it over here. Half of 56. So half of 50 is 25. Half of 6 is 3. So that makes 28. Okay. All right. 28 is an even number if you still don't know your times tables. Half of 28 is 14. 14 is an even number. Half of 14 is 7. And 7 is a prime number. So that is where we stop. And 2 is also a prime number, the only even prime number. So our prime factorization here is all our circled numbers. 2 times 2 times 2 times 2 times 7. Now, check this out. Anything squared means times itself, right? So here, 2 times 2, right? 2 times itself can be rewritten as 2 squared. And another 2 times 2 can be rewritten as 2 squared. And then we've got our 7 there. All right. Now, at this point, I'm going to break it up, and you'll see why I rewrote these as 2 squared. If I rewrite this as square root of 2 squared times square root of 2 squared times square root of 7. This is just applying this rule to here. The 3 things being multiplied inside the square root can be split up into 3 separate square roots. Okay? Here's why I do that. Because we all know from our studies this year that square root and square cancel out. Remember how we'd have square root of x equals 5, and we would cancel out the square root with a square, say x equals 25. Yeah. So square root and square cancel out, then this is now just 2, because the square root and the square canceled out. This is now just 2, because the square root and the square canceled out. And my square root of 7 is still there. 2 times 2 is 4. So we have 4 root 7 as our simplified radical. Square root of 112 is the same as 4 root 7. Now this is kind of a long way of doing it. If you know your perfect squares, if you know how to factor quickly, then you can do this kind of stuff in your head. But I do it kind of this long methodical way so that those who aren't already fluent in their times tables can see that they can do it too. Okay. So that's square root of 112. Let's keep going. Let's do square root of 75. Again, not a perfect square, somewhere between 8 and 9, right? 64 and 81. So let's factor it. Now it's not even, but it does end in 5. And I know that anything that ends in 5 is divisible by 5. So I got to figure out what 75 divided by 5 is. Don't even know that off the top of my head. 15. Now 5 is a prime number, so I'll circle that. 15 also ends in 5, and it is 5 times 3. 3 is also a prime number, so boom. All right. So square root of 75 be rewritten as 3 times 5 times 5. Okay? And when you have two numbers the same, I can write them as a square, right? 5 times 5 is 5 squared. I can split this up now. Square root of 3 times square root of 5 squared. And again, square root and square cancel out. And in mathematical formatting, I'm always going to write it with the number that's not under the radical out front so that it is clear that it is not under the radical. Otherwise, it might accidentally get extended somehow. So 5 root 3 is a simplified version of square root of 75. I've noticed I really don't use these in this big list I've given you. I would use these if you were doing it kind of a short and easy way. Because my short and easy way of doing this one is I would look at 75, know right away that, 3/4 is 25 times 3, and then just say, oh, square root of 25 is 5 root 3. And then I would use that if I didn't know what square root of 25 was. But so that's square root of 75. All right. Let me see. Let's do square root of 200. Okay, square root of 200. So my first thought, we could say this is even, but I also know anything that ends in 0 is divisible by 10. So how many times does 10 go into 200? 20. Now, 10 and 20 are both even numbers. So 2 times what is 10? 5. 2 and 5 are both prime. 20 is an even number, so it also is 2. And it's 2 times 10. And we already know what 10 turns into. 2 and 5. Okay, I like this one. I'm going to show you. So we've ended with all prime numbers. I've got 2 times 2 times 2, 3 2s, times 5 times 5. So, finding squares, finding perfect squares. 2 times 2 is 2 squared. Then I have this extra 2, and I don't have another one to make it a square, so it just stays as 2. And then 5 times 5 is 5 squared. So, just because you have a bunch of 2's doesn't mean they'll all come into a square, right? This has 3 2's, so 2 of them can form a square, and 1 is left all alone, right? So I can split it up, 2 squared, square root of 2, and square root of 5 squared. Okay? Cancel my square roots and squares. What I end up with is 2 times square root of 2 times 5. 2 times 5 is 10, so 10 root 2. And again, if I was doing this like a fast way that someone who's familiar with square roots can do, I would just do this. I would say 200 is 2 times 100, square root of 100 times 2, square root of 100 times square root of 2, 10 root 2. And I can do it that fast way because I know and can see right away, hey, I know 100 is a perfect square, 100 goes into 200, boom. But if you don't instinctively know 100 is a perfect square and that 100 goes into 200, then you do it kind of the long way. So whichever is easier for you. Okay, I think I'm going to stop there because the video is already 17 minutes long.